Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are two of our students who I will let say hi and introduce themselves. And we'll start with Lynn, since they are right next to me.
Hi, I'm Len. I'm a physics and astronomy student here at UMD.
Hi, I'm Luis. I'm a chemical engineering student.
All right, well, tonight, sorry, my phone just buzzed. Distracted by everything. Tonight is our monthly installment of Ask an Astronomer, so we are here to answer your questions. I know we've already got one from my mom. Hi, Mom. And it is, of course, about the big topic of today, which is the launch of Artemis I. So I think we'll just jump straight into that. Sound good? Okay. Did y'all get to watch? Did y'all watch the launch last night? No? I'll be honest, I kind of didn't either. I feel horrible. My husband is like shaking his head in shame at me right now. I admit it. I admit it out loud. I didn't. But as all things, there is a video. And so I figure since a lot of us probably didn't get to see it since it happened at like 1 o'clock in the morning, we'll start off with the video of the launch, and then we'll talk a little bit about what was going on. And since you didn't see it, oops, there we go. Facebook went black there for a second. I will share so that everyone can see. Okay, so let's do this.
The rocket, it will take over command and
You'll have
control
sound.
of the rocket.
Please.
But the ALS will check, make sure there's no holds coming from the ground.
I'm not getting anything.
I think I might have forgotten to share sound. Yes, I did.
I think it's coming through.
Yeah, it's coming through now. I've just
up until
been a little delayed.
Go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now
15.
Flowing under the ML. And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q in about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour.
It's crazy.
You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now.
Okay, we'll go to that stage and then I think we'll stop.
As teams continue monitoring the flight of Artemis I. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion, all four RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
Okay, I'm gonna pause it there so that one, our stream isn't just entirely this. Because I will sit here and just watch the last hour of this. Okay, so first thing I'm gonna do, because I forgot to do this, I'm going to put the link to the stream, to the NASA stream, in the comments so that people can go and see it and watch it for yourselves. But let's talk about what's going on. So this is the launch of Artemis I. Artemis is our mission to get people back to the moon. Named so because Artemis is Apollo's sister, and Apollo was our first missions to the moon. It's also hopefully a stepping stone to getting to Mars, where we would use the base, a base on the moon as kind of a pit stop, I think is fair to say, to then get to Mars. So this launch of Artemis I is the first full test of the system. It is unmanned, and the goal with Artemis I is to launch it, have it go to the moon, orbit around the moon, and then come back to Earth. And it is a way to test all of the systems, which leads into the first question that we got, which is basically asking why are they doing this step of an unmanned test if we've already sent people to the moon? The very, very short, sweet answer is this is an entirely new system that we didn't use last time we sent people to the moon. So we, of course, want to make sure that we test everything before we actually put people on it and make sure that everything works. And that's the simplest answer. I know Artemis I is also launching some satellites that are going to be placed on the way from Earth to the moon that are going to help with future communication with future missions. So getting that in place is also important as well. So biggest, it's new. It's a new system, new rockets, new space system. Yeah, everything's new. So we want to test it before we put people there. But that is the next, assuming everything goes successful with Artemis I and it comes back with no problems, the next Artemis launch will have people, which is exciting. It's like, I was talking to my husband about this last night, how, like, I know we have had people on the moon, but that feels like it's history, right? It doesn't feel real. I know it happened. I've seen pictures, seen the videos, not a moon landing denier. I know it happened. But, like, to know that, like, we could actually see it in real time, like, that's crazy. I'm very excited. I don't know. How do you two feel?
It's really cool. I'm excited too.
I'm really excited too. Yeah, because I always would hear my mom telling me about how she just like has the like sliver of a memory of the moon landing from when she was a kid, and I've always heard that. I've been like, whoa, I want to have a memory like that. Now we actually can, because we're gonna have another moon landing. It's really cool.
And maybe have Mars next. We'll see. Which is even crazier to think about. And I mean, yeah, we've been launching people up to like the International Space Station for a long time. This is significantly more difficult because the International Space Station is in low Earth orbit. It's really not that far up, which means we don't have to launch a rocket very fast in order to get to those heights. To get to the moon, we have to essentially escape Earth's gravitational pull. Not fully escape, because you can't really escape gravity, but that's a whole other tangent. But we have to be able to move away faster than Earth pulls us back. And that is incredibly fast, which makes the rocket you need a lot bigger, which requires a lot more fuel. It's also a long trip. It's several days over, instead of a couple of hours. So you have more provisions that you have to take for people. There's a lot involved in it, but it's happening, guys. It's happening. Oh, okay. I know we got another question that is not Artemis related. So, do either of you have any last closing thoughts on Artemis?
It's gonna be really cool. Can't wait for the Lego set.
Oh my God, I know. They already do have,
That'd be cool.
have like a moon base set.
Mm-hmm.
And which is a little bit different than the one we raffled for Halloween. We did raffle a, what was it? It was like a moon space station or something that's was based off of the Artemis mission, but it's not like an actual scale model. I can't wait for the scale model. Yeah. Gotta add it to the collection. I have them all.
Lego knows its audience really well.
It does. I'm still waiting for Perseverance. Like, I'd love a Perseverance one. It's fine. It's fine. Need to save some money anyway.
Oh yeah. Legos are getting so expensive.
Between the NASA ones and all the Harry Potter. God, there's so many Harry Potter ones I want.
Mm-hmm.
Like the giant castle. It's like $600. But anyway, we're getting very off topic.
How it is, we're just talking. We're asking astronomers different questions, like which Lego set would you pick?
All of them. That's the only correct answer. All of them. Oh yeah, so since I bought the Office Lego set, if anyone doesn't know, I'm a huge Office fan. So when they came out with a Lego set for it, obviously I had to get it. They started sending me their Lego catalog.
Oh, that's dangerous.
It is so dangerous. I have found so many. Anyway, pulling us back to tonight. So, let's see. It looks like we did get another question about Artemis. Does anyone know why Artemis has a launch window? Really, it's configuration of the Earth and Moon. You need them to be at the right places, the right locations, in order for it to be pretty easy to get there. A lot of these trajectories are mapped out ahead of time. And like you said in your comment, a lot of it is to make fuel efficiency and shortest trip possible and all of that. And so that's where the launch windows come in. I don't remember how long Artemis is supposed to orbit. I hear typing. Are you Googling real quick? Because I know the entire Artemis 1 mission is supposed to be anywhere from 25 to 47 days. So I think the orbit, the number of times it's going to orbit is going to depend on a few things. And part of that is also making sure you're in the right configuration to head back as well. But, yeah. And I did, if anyone missed, in the video description, there are a couple of links to NASA's site with Artemis information. So you can find all sorts of information, including the depiction of the path that it takes, all of the major milestones, all of that. You can find that at those links. All right, well, I think we can head to the next question that we had, we'll move away from Artemis. And the question is, you got it?
Yeah, I'll probably take it because this kind of goes into what I wanted to show at least.
Okay, go for it.
So it was the formation of planets. And so they don't just kind of float around and like find stars. They are created after the star is kind of has its energy system going basically. And so if I can share my screen.
Yeah, you should be able to.
We're going to be going to James Webb telescope picture, which I hope it's showing. It should be showing.
Oh,
and so this
so
is
pretty.
Yeah, it's amazing. It's a protoplanet that's just starting to form. And so it's not a fully formed star yet. It's going to take, it's a fairly young star. It's only 100,000 years, which
very young.
It's very, very young. But so all this dust around the hourglass shape that you see is all the dust that the sun is taking in to start its energy. And then anything that's left over from that kind of dust cloud starts to turn into planets as the sun starts to rotate around and create more centrifugal energy, basically mashing all these smaller rocks into bigger rocks that then form the planets in its own solar system, basically. So honestly, that question really led me, or it was just such a good setup for this, I think.
It was.
But it's such a pretty picture to just look at too.
Yeah, and so to say a little bit more, it's might be hard to see on the screen, but at the very center of the hourglass, you should be able to see a thin, dark line. Yeah, he's pointing to it. Yeah. Or zoom in. Yeah, that works. That is the disk of gas and dust that's surrounding this newly forming star. So everything you're seeing coming up and above, that's light that's being scattered up and down. We don't really see light going out the sides because that disk is so full of dust and gas that it blocks the light from going out this way, and so the light comes out the top and bottom. And yeah, in that little disk, you got the protostar, young star, forming at the center, and then around it, in this swirling disk of gas and dust, you'll have planets that form. And this seems to be just a natural part of star formation. It's what happens. Yeah. Planet formation is a byproduct.
Or just here by coincidence, I guess, or just here as an afterthought.
I would say afterthought. I mean, it's what happens when you get a collection of stuff that starts forming a star. You start forming planets out of the extra bits.
Mm-hmm. So yeah, honestly, that was a really good question as well to have. So.
All right. Well, let's see if... That was a really good question. I love talking about planet formation. Like, it's so much fun to talk about. And just, it's one of the things that, like, some people don't think about it, but, like, one of the reasons we want to study asteroids and comets is not just to study these things, but those are planet pieces. Those are made of the same bits that planets formed from. So learning about those teaches us about what went into the process of creating a planet. And that's why, so I've got my time to brag, right? I've got this wonderful little thing. This is a meteorite. This is from the Allende asteroid that crashed. And if you can see, let me take off its top so it's not quite so dusty. If you can see those tiny little white bits in there, those are called calcium aluminum inclusions. Those were the very first solid grains to form as the planets formed. Those little white specks. It's so cool. And that's why we study these. That's why they're so important. And also why I have one, because I got to touch it. Because museums won't let me touch things, so I got my own so I could touch it. I'm not kidding.
Was that expensive? Like, did you just find it online or something? Or what?
I don't know for sure. It was actually a gift from Sage.
Oh, that's really sweet.
Right? He kind of won with that one.
Oh yeah.
And it was specifically because we saw one in a museum, and I made a comment of I want to touch it, and so he bought me one so that I could touch it. Okay. Enough gushing over how sappy we are. Oh, all right. Well, let's keep questions coming. If anyone else has other questions, put them in the comments. Lynn, did you have the thing about the black hole?
I do, yeah.
Yeah, you want to talk about it? Yeah.
Sure. So in my reading today, I found out that as of November 4th, astronomers have discovered the new closest black hole to Earth. So previously there was a black hole that we knew of that we considered the closest one to Earth, but they just found a new one. They named it Gaia BH1, and it's about 1,600 light years away in the constellation Ophiuchus. So it's a stellar mass black hole, and it's currently it's dormant, so it's not like emitting any X-rays or anything. It's not like consuming material. It's just kind of hanging out. But they actually found it by observing the effect that it has on its companion star, because it's essentially like the system that it is. It's if you were to replace our sun with a black hole and then replace the Earth with the sun, that's essentially the system that they saw, and they watched as this star moved back and forth, and they used the subtle like shift in the gravitational, like the movement of the star, to figure out where this black hole was, which is pretty cool.
And it's similar to how we find planets. We do the same thing watching, except it's the tug that a planet has on its star, which is cool. Did you, sorry, I was looked down, like reading something for a second. Did you say how big the black hole was?
It's about 10 times the size of our sun, or 10 times the mass.
Okay. So still a stellar mass black hole. That's cool. And I know one thing you said in there may take some people by surprise. You said, if you take our sun and put it at where the Earth is, a lot of people immediately go, oh, but wouldn't it get sucked in? But, like, that's the thing. Black holes aren't these infinite vacuums, right? You have to get within the event horizon. That's the point of no return. So for a black hole 10 times the mass of the sun, that would be, I believe, about 10 kilometers. If I'm very, very quickly doing that math correctly in my head. I think that's right. Either way, it's not very far. Like, you could even be at Mercury's orbit and be fine. So, yeah, they're not these scary cosmic vacuums that are just going to suck everything up. You're fine unless you just get too close. Then you might have problems. But then we get into my favorite term ever, spaghettification. It is the real scientific term, and I love
really
it.
Good word.
It's so good.
It's so good. It's the perfect description of what actually happens.
And it's crazy going between, like, astronomers are either super clever with coming up with names or absolutely horrible. Like, oh, we have a spot on the sun, it's a sunspot. Oh, we have a very big telescope, it's going to be called the Very Big Telescope. I think it's Very Large Telescope, but whatever. Or we have galactic cannibalism or spaghettification. Like, be consistent. Make everything awesome.
Well, and of course there's Milkdromeda too.
Oh my goodness.
About Milkdromeda.
That one's just funny.
That one is so bad. We need a new one. So that is the name. Sorry, pulling my blanket up. The heat in our place doesn't work right now, so I'm a little chilly. It's fine. It's better than it being on full blast all the time and us not being able to turn it off. But that's another tangent. So yeah, that's my blanket. Milkdromeda is so the Milky Way galaxy and the Andromeda galaxy, which is the closest major galaxy to us, are on a collision path. They're gonna collide and merge. And the fabulous name that has been come up with for the mega galaxy once these two merge is Milkdromeda, which I'm pretty sure everyone I have met despises.
I don't know. I kind of love it. It's bad enough that I think it's perfect.
Oh, you haven't convinced me. Oh, yeah, no, that would be. So we'll see. And that's another thing that like sounds scary, right? Galaxies colliding when it's not actually. So space is mostly that, mostly empty space. I actually read a really good analogy today to kind of help with understanding how much space there is. So like if you were to take the Milky Way galaxy and shrink it down to be the size of the United States, okay? The average distance between stars would be about the size of a football field. So you have stars separated by football fields in length. But the stars themselves would be the size of a cell, a human cell, like skin tissue cell or whatever human cell, organism cell you want to come up with. That's how much space there is between things. So when we talk about galaxies colliding, you're not really having stars run into each other or planets run into each other. You will have the giant gas clouds run into each other, which then creates new stars. So a galaxies merging is actually more of a creation event because you get a whole bunch of new stars triggered by those clouds merging together and slamming into each other, rather than a whole bunch of stuff being destroyed. So it's actually kind of beautiful. You get whole new baby star systems formed. All right. I feel like I've gone on a lot of tangents tonight. This has been fun talking about, though. I have enjoyed it.
Gotta have a little fun on live streams, you know?
Oh, yeah.
At least a little bit.
I also feel like, so this is getting into what I was next going to talk about. I almost feel like I want to put in a little extra since we're not streaming next week. And so it's just like, this is my last time to see you guys, our lovely Facebook fam, for, 2 weeks. So since I brought that up, let me go ahead and just tell you about the upcoming schedule. We do still have our shows this weekend. So we've got Friday is Adventure to the Edge of the Universe. And then Saturday, our 2 p.m. family show is Polaris, the Space Submarine, and the Mystery of the Polar Night. Louise, are you sick of that one yet? Oh, he's gone. Okay, I'll tease him about it later. And then Saturday night is From Earth to the Universe. And then, next week we are not doing our stream or any of our in-person shows because most, if not everyone, is going to be gone for the Thanksgiving break. So we are taking the week off, but we'll be back here the week after on November 30th with our next live stream, which will be What's Up December, since that's last day of November, so it seemed appropriate to talk about the upcoming month. So yeah. All right, well, we'll do one last call Been a lot of sirens going on outside. Sorry about that.
Sorry, I had a puppy yelling at me.
You didn't show the puppy?
I can try to grab him. He's not a puppy. He's like 2 years old, but
Oh,
can
all
try
dogs
to
are
grab him.
puppies. All dogs are puppies. I mean, you can't say there was a dog and not pay puppy tax. Puppy. Hi there. Okay, what's his name?
Johnny
Oh,
is the new guy here. But no, he always gets fed at 7:30, so he
right
knows
on
what time it
time.
is. He knows what time it is.
He's got a good internal
It's a little
clock.
early sometimes, but yeah. Just
Is
saying
he
that.
early or are your clocks running behind? Like,
That's true. We never know.
oh, I'm very excited. That seems like a fantastic way to finish off the stream tonight. And puppy needs to be fed, so I think we need to wrap up. All right. Well, thank you everyone for joining us. As I said, no shows next week, but we will be back the week after with our regularly scheduled shows for a few weeks before we take off for the winter break. But have a wonderful rest of your week, a lovely holiday next week, and we'll see you all later. So, bye everyone.